All right, we have one last type of factoring to look at. This one involves sum and difference of cubes. If you take a look at this table, we have perfect cubes highlighted in yellow. So 1, 8, 27, 64, 125, etc. When you start to see these, you should notice that these are perfect cubes, okay? The other thing we have is sum and difference now, okay? Addition and subtraction. This is going to be different than when we did difference of squares, a squared minus b squared, where we only had subtraction, okay? We couldn't do anything with addition, so this is a little different in that regard. All right, here's the pattern we're going to use to factor sum and difference of two cubes. Go ahead and copy these down here. Now, here's the thing. Those look a little complicated, but you might see my drawings over here. We have a Christmas tree and a bar of soap, and that's going to help us remember this pattern here, okay? Because we're going to use Christmas soap. Christmas soap. That's going to help me remember how to do this, okay? All right, let's take a look at this first one. We are asked to factor x to the third power minus 8. The first thing I want to look at, so first of all, it's difference, okay, subtraction. So this could either be difference of squares or difference of cubes, and that's where we need to recognize that we have, first of all, x to the third power. We can't, that's not a perfect square. We can't pull out factors of 2 from that. The other thing is 8 here is not a perfect square, it's a perfect cube. So we're going to do difference of cubes. All right, here's that pattern over here, and let me explain why we're talking about Christmas soap. This is how we're going to remember what terms go where, as well as the signs. All right, first thing we're going to start with is my signs. All right, so if you notice, I have difference here, okay, subtraction. So for my signs, we're going to turn this difference of squares, a binomial, into a binomial times a trinomial. And here's how we're going to use the soap to remember the signs. This first sign here, S, is the same as the original, okay, S. This next one is O for part of soap. This is the opposite sign. And then this last sign here is AP, which is always positive. And that's where we get our soap, okay? S-O-A-P. Same, opposite, always positive. Now, for Christmas, we're going to do C-R-S-M-S, all right? Christmas without the vowels, all right? You're not buying a vowel here. C-R is going to be the cube root, okay? Then S is going to be square the first term. M is going to be multiply the two terms together. And then S again is going to be square the second term. All right, it takes a little practice. I'm going to do 3 of them here with you. Just remember, you're asking for Christmas soap this year, okay? Because it's going to help you factor. All right. X cubed minus 8. We decided that this was Christmas soap. This is difference of cubes. Here's what we're going to do. So first of all, we're going to start with a binomial, 2 terms, times a trinomial, okay? For those signs, we're going to remember soap, S-O-A-P. So same sign as above, subtraction. Opposite sign from that is addition. Always positive is addition. All right, what holiday? We're talking about Christmas. So C-R-S-M-S. The first thing, I'm going to take the cube root of that first term, okay? So the cube root of x to the third is just x. So that first term is x. All right. The next thing I'm going to do is take the cube root of that second term. So the cube root of 8 is 2. Okay, so CR is the cube root of each of those terms. Now, the signs are already there, so don't mess with the signs at all because soap got us the signs. At this point, I'm just going to use the x and the minus 2 to fill in the rest of this trinomial here, okay? This first s is squaring the first term, so x squared. This m is multiplying 2 together, so we have 2 and an x. Again, don't worry about the signs, we already did that. 2x, and then the second s is square the second term, which is 2 squared is 4. That's it. Christmas soap. So that's my factored form. Whenever you do difference of squares, I cannot go any farther. That trinomial is never going to be able to factor any farther than that. Okay. All right, let's do 2 more. Again, Christmas soap helps you remember that pattern so that you don't have to remember just this crazy thing all by itself, but you have to see it done a couple times, and that's going to help you out. All right, next one here. Whenever you have 2 terms, usually, again, so first of all, check for a GCF. Then it's either going to be difference of squares or sum or difference of cubes. This one has a plus sign, so it's already, I know it's a sum. We can't do squares. It's going to be cubes. And then I also see a 27. I see m to the third. I see 125. These are screaming at me, hey, take the cube root of me. Okay, so we're going to use this pattern on the right here. But we're not going to remember that. We're just going to remember our Christmas soap. Okay. So first thing, signs, same, opposite, always positive. And then we're going to just do Christmas to fill in the terms. Okay. All right. So we're going to turn this into a binomial times a trinomial. Let's fill in the signs first. Okay. Soap for my signs. So same sign as above, since we're dealing with the sum of cubes, we're going to use that same sign, a plus sign. O is opposite from that, so we're going to put a negative sign, and then we're going to go back to always positive. All right, it's almost Christmas, so let's remember that Christmas, again, smelled a little funny, but we got to do what we got to do to remember this. Okay, CR, cube root. So I'm going to take the cube root of 27m to the third. Now, the cube root of 27 is 3. The cube root of m to the third is just m. Now I'm also going to take the cube root of that second term, and the cube root of 125, look at your table, is 5. 5 times 5 times 5 is 125. At this point, we have our 2 terms. We're just going to use those to fill in the rest of Christmas, okay? The SMS of Christmas. So I'm going to square that first term, okay? So down here, square 3m. And so basically, remember, 3m squared is really 3m times 3m. So we have 3 times 3 is 9. M times m is m squared. So squaring the first term gives me 9m squared. All right, middle term, we're going to multiply those 2 together. So we have 3m times 5, which is 15m. And then this last one here, we're squaring the last term, so 5 squared, 25. All right, again, don't do anything with those signs. They're already there. So we're just taking the 3m and the 5, and we're using those terms to fill in the rest of that. All right, we are getting this pattern down. There is my factored form. Hey, for fun, if you want to FOIL this back out, distribute this back out, combine a bunch of like terms, you'll see that we get 27m to the third plus 125. Okay, we're just putting it into factored form. All right, one more here. Okay, we have difference, so subtraction. So I could have difference of squares, right? I could have difference of cubes. Now, take a look at your table, 128, 54, x to the third. I don't see any of those numbers on there. That's the only thing with this one. So what do we do? What do we do? Hey, we take a GCF, right? We always look for a GCF at the beginning. If you notice, I have 128 and 54, both even numbers. So I'm going to factor out my greatest common factor here is going to be 2. All right, if I factor out a 2, I'm left with 64 minus 27 x to the third. Ding, ding, ding. Look at your table. We've got perfect cubes now, okay? So remember, when you factor out a GCF, it doesn't go away, right? We're not dividing by 2. we're taking out a 2 from the expression. So it has to stay there, otherwise we've changed it. So don't forget that 2 along the way. Okay, at this time we have, again, we're just going to deal with the 64 minus 27x to the third, and that's going to be our difference of cubes. So I'm going to leave that 2 and then turn the rest of it into a binomial times a trinomial. My signs are SOAPy because I have the same sign as above, which is subtraction. Then I have opposite, which is addition. Then I have always positive. All right. My terms are the cube root of the first and second term. Then I'm going to square the first, multiply them 2 together, and square the second. Cube root of 64 is 4. Cube root of 27x to the third is 3x. Squaring the first term is 16. Multiplying them together is 12x. Squaring the last term is 9x squared. All right, so there we go, factored form of that original expression. Again, sometimes it doesn't scream a certain pattern that we know, but that's why we always want to take a look and see if we can get that GCF. All right. A lot of different types of factoring with this and the Wednesday homework. It's a lot of stuff, but I will be back next week and save your questions. I will answer them all. Have a good day. Have a good weekend. I'll see you soon. Bye.